Okay, so last couple of things in this range of 100 tons to 1 million ton are space flight and sorry, I don't know why I'm doing this. Okay. A space shuttle flight is what is mentioned in the book, but space shuttle formally doesn't exist. So let's just say space flight, and now it's become a big discussion because Musk, Bezos, and Branson have all created flights to space, and Branson went up in the upper atmosphere, Bezos went up in the upper atmosphere, took some people with them. Elon Musk wants to make it affordable to all human beings as well. And Bill Gates said they should stay on Earth because there are plenty of things to do here. And already plenty of articles have been written about how much these billionaire space flights are going to cost in terms of carbon footprint. So here, at least 4,600 tons of CO2 equivalent for a space shuttle flight. That's the same as 2 bananas for everyone in Canada, or half a sheet of recycled toilet paper for everyone in the whole world. So that's over 7 billion people. Well, space flight is interesting. It motivates humanity, gives kids excitement about flying someday, and so on. So we have to worry about carbon footprint, but exploration of the space beyond Earth and solar system are obviously exciting things for the future. Looking at a few rockets here, this is CO2 emissions per passenger. So we look at the total and number of passengers and then per person. So I won't say what these all are, but we can compare these space flights to Boeing 747 and Boeing 737. So total CO2 metric tons goes from 425 to 2,683 down to 60 for a smaller 737. Number of passengers here is 443,100 in the Starship, that is super heavy. The regular Starship is 400, so you have to figure out what the differences are. And Boeing 747 carries 416 passengers when it's crammed full, and Boeing 737 is much smaller at 180. So CO2 per passenger then works out 106.25 in Falcon 9, 64.75 in Atlas. Starship, this one is big, it's at 26.83, but carries 100 passengers. This one drops quite low because it's estimated to be able to carry 400 passengers, so down at 1.79. And there you have Boeing 747 and Boeing 737 at 0.73 metric tons and 0.33 metric ton per passenger. So that gives you a sense. How do we compare then? So if you think about the number of launches by rockets versus number of flights, then you have 331,579 times more flights than rocket launches. Orbital launches in 2018 were 114. Commercial flights in 2018 were how much is it? 37,800,000. Okay, so that's the big difference. So even though per capita footprint may be small, airline industry's annual ton of CO2 in 2018 was 918 million. Okay, so that's pretty massive. Tons, 918 million tons, 40,300 times more. Spaceflight industry annual ton of CO2 was 22,780. So we may be a long way from spaceflight becoming as common as the regular flights we have. So maybe we don't need to worry yet, but nonetheless we need to keep in mind the massive carbon footprint that comes with what is being explored now by Musk, Bezos, and Branson. But these are kind of the Wright brother moments for space travel. So see where we have come from the little hop that the Wright brothers took in the early 1900s to what we can do now. Of course, there is huge carbon footprint, but nonetheless, if we say we are going to reduce carbon footprint and make spaceflight more fun and affordable, then I would be all for it, right? Finally, a university. Depends on how you do it. This is for Lancaster University, 72,000 tons CO2 equivalent per year. So that's about 5.5 tons for each staff member and student. The figures here are based on a study for the Lancaster University. It included just about everything you can think of: gas, electricity, commuting, business travel, and everything the university buys, right down to the paper clips. It even included intangibles such as software and banking services. It didn't include everyday food because the university only caters for special events. Of course, most universities have cafeterias, canteens, food courts, food wastage, unhealthy food, fast food, junk food, whatever, are all there. The carbon footprint for Lancaster University turns out to be dominated by purchases and electricity, which includes running computers as well, which is a big chunk. I think 12% in this case out of the 28%. Gas, water, sewage treatment, business travel, commuting, and so on, right? Lancaster cannot directly be applied to other universities, but there is a paper which did some objective metric to compare universities across the globe. So locations and carbon footprints performances of 20 universities, fully rated, allowing a relative comparison and ranking 1 to 20 in total carbon footprint performance, which is given in a table. I won't go through that. The lowest carbon footprint, best performance, each found for constructed area. So here in green, per capita in red, per expenditure in blue is given the same column height. These three minimum carbon footprints are marked by an asterisk. So ETH Zurich and University of Lüneburg end up in this category. In each category, the relative column height corresponds to the absolute values as shown in figure 3, which I'm not going to show. For calculation of the carbon footprint performances, see appendix and so. Well, anyway, you can see that the range is quite high, from 526 kilograms CO2 equivalent for the blue, which is expenditures. So red is per capita, green is constructed area, and blue is expenditure. Nonetheless, you can see the ranges are different in different categories, and Cape Town is quite high. Zurich and Lüneburg are here ranked very high in this categorization. So just relatively speaking, whether it's in the global south or global north, universities should be leading by example on climate action. So hopefully doing carbon footprints is a start to see how they can reduce their carbon footprint, especially compared to national footprints. So here is a comparison of national footprints, university carbon footprints per capita and year relative to national per capita footprints, the latter for 2015. Areas shown for Australia, US, European countries with universities covered in this investigation. This is in metric ton CO2 equivalent per capita. So Australia has 15 million tons? Metric tons, sorry, per capita CO2 equivalent, and universities are much smaller. That's good. US at 20 metric tons CO2 equivalent per capita, much lower. The European Union has a large range, and the university range is also a little bit over close to 0 to 2.6 or so. This is Singapore, which is done a great job of doing sustainability measures, reducing carbon footprints and so on, but still the average person has a carbon footprint of 10 metric ton CO2 equivalent per capita, which is not that low, right? It's a very high technology little state country which has a lot of driving, surprisingly, for the small space they have. Mexico, Chile, China, Malaysia, and South Africa. Okay, so that just gives you a sense of space flights and universities. Space flights are exciting. Universities are important. Both can reduce their footprints. Space flights is going to be dominated by rich people for a long time who may or may not care about carbon footprint while they establish the business model for ferrying people to space and back. Amazon is even announced that it's going to build a space station, for example. China is building a space station. US and Russia, there is an international space station as well. So just keep the things in mind. I don't know what else to say. Universities should definitely pay more attention to reducing their carbon footprints. This is obvious.